Hi everyone, got the practice test to go through here. Number 1 here on this practice test, find the exact roots of 2x to the 4th plus 5x to the 3rd minus 14x squared minus 29x minus 84. I will tell you, if we go through the rational zeros, it is going to take a while because there's a lot of factors. 1, 2, 3, 4, 6, 8, 9, but see, 12, well 7, 12, and then 14. There are a lot of factors of 84, and then double that because we have all these 2's here. We have some overlap there, I'm sure, but I'm going to actually give in and graph this and look for, see if any of those would be reasonable zeros, thinking of the rational zero function while we're doing that. So I got 2x to the 4th plus 5x to the 3rd minus 14x squared minus 29, oh dear, I wasn't looking. Okay. 5x to the 3rd. You guys were seeing this. I wasn't. Minus 14x squared minus 29x minus 84. All right, let's look at the graph of that. Okay. Looks like -4 and -3 might be possible zeros. So I'm going to start with -4 and go 2, 5, -14, -29, -84, using synthetic division here. 2, -4 times 2 is -8. 5 and -8 makes -3. -4 times -3 is +12. -14 and +12 is -2. That's 8. This is -21. -4 times -21 is +84. So that's good news that -4 is one of the roots. I'm going to use the word zeros. Zeros and roots are the same thing. So -4 is one of them. And I'm going to try -3, but in the smaller one here, I've got 2x cubed minus 3x squared minus 2x minus 21 is my smaller polynomial now that I've factored out x plus 4, essentially. So I've got -3 and then 2, -3, -2, and -21. Bring that down. -3 times 2, that's -6. -9, that's 27. Let me see what I'm doing here. Okay, I'm looking, that's not going to work, and the reason it's not going to work because that is not -3, that's +3 here. So good check here. 2 times 3 is +6. This makes 3. -3 and 3 times 3 is 9. -2 plus 9 is 7. 7 times 3 is 21. So yeah, that gives me a 0 there. So 3 is a 0, not -3. And now I've got 2x squared plus 3x plus 7 to find the other roots. I'll set that equal to 0. I don't think this is going to factor, so we are going to use the quadratic formula. X equals -3 plus or minus the square root of 3 squared minus 4 times 2 times 7 over 2 times 2. And that's -3 plus or minus the square root of 9 minus 56. That's -9 minus 56 is -47. over 4. So negative 3 plus, oh, I'm going to write that as the square root of 47i over 4, and negative 3 minus the square root of 47i over 4. All right, so those are the zeros of that one. Okay, let's do this next one, product of linear factors. I'm going to retype this. No, there's a little similarity there. So it's got a minus 5x cubed plus 9, let me delete that, x squared minus 30 x minus 18. All right, let's graph that one. See if we can get any clues here. All right. As I look at the intercepts, that looks like half. I think I'll try half here. 1, 2, 3, and that, oh, negative 1/2. I really got to be careful with these signs, don't I? And that looks like 3 there. So let's try negative 1/2. Let's see where that takes us here. 2, negative 5, 9, negative 30, negative 18. So the finding the zeros is, I think, the first step we want to do here. Negative 1/2 times 2 is negative 1. That's negative 6. Negative 1/2 times negative 6 is positive 3. That is 12. Half of 12 is 6. Negative 6 here. Add those, that's negative 36. Negative 1/2, negative 36. That is positive 18. So that did work. Negative 1/2 is a 0. So we're looking at 2x cubed minus 6x squared plus 12x minus 36. And I want to try the 3 in that smaller polynomial. The 2, negative 6, 12, negative 36, just to make sure that is a 0. 3 times 2 is 6, that's 0. 0, we got 12, that's 36, which does give us a 0. So I'm looking at 2x squared plus 0x plus 12 equals 0. And I'm going to subtract 12. This time, I'm not going to use quadratic formula because b is 0. You can, it'll work. I think it might be a little easier just to solve this way. So I got x squared equals negative 6. And x will equal plus or minus the square root of negative 6, which is plus or minus the square root of 6i. All right, so negative 1/2, 3, square root of 6i, and negative square root of 6i. So this is a product of linear factors. If these are zeros, we're talking, let me do it down here. F of x equals x minus 1/2. Nope, x plus 1/2, x minus 3, x minus the square root of 6 times I, and x plus the square root of 6 times I. Now I'm noticing something here. We got an issue. X times x times x times x is x to the 4th. I need 2x to the 4th. So it's not a big deal. I'm going to put a 2 out here in front. And I'm actually going to distribute that 2 to the first term. I can distribute it to any of the terms. I'm going to multiply those two together. And that looks like 2x plus 1. x minus 3, x minus the square root of 6i, and x plus the square root of 6i. Okay. All right, number 3. Write a polynomial with integer coefficients of least degree which has 2, -7, 3 plus 3i is zeros. I'm also going to put 3 minus 3i because of the complex conjugate theorem says that if we have real coefficients, the conjugate of a complex zero is also a zero. So my polynomial will have x minus 2 times x plus 7 times x minus 3 plus 3i times x minus 3 minus 3i. Notice the minuses are always there. I'm going to multiply these two together. X squared, 7x, and negative 2x is 5x, and negative 2 times 7 is negative 14. Okay. And this, I'm going to multiply those together. I'll use a box this time. Haven't done that in a while. Okay. X, negative 3, negative 3i. This is x, negative 3, and positive 3i. Double negative there. So x squared, negative 3x, negative 3ix, negative 3x here, positive 9 here, positive 9i here, 3ix here, negative 9i here, and negative 9i squared here. Negative 9 times negative 1 is 9. So I'm going to use 9 in that box instead of negative 9i squared. And what are we talking here? X squared, negative 3x, negative 3. Well, let me cancel those out while I'm thinking about it. Minus 6x, 9 plus 9 here is 18. All right, I'm not going to use a box this time. I'll just loop them here. X to the 4th minus 6x to the 3rd plus 18x squared. 5x times x squared is 5x to the 3rd minus 30x squared plus 90x. 18 times 5 is 90. Negative 14x squared. Just line these up. Be easier to combine at the end. Negative 14 and negative 6 is positive 84x. And negative 14 times 18. 126, 252. Negative 252. X to the 4th minus x to the 3rd. 18 minus 14 is 4 minus 26 x squared plus 174x minus 252. I'm going to stick with that one. Okay, that's the end of the polynomials. Let's do a little bit of trig here. Determine the measures of two coterminal angles, one negative and one positive for the angles given. And if I look at it visually, negative 87, here's my initial side, my terminal side be right like here, really close to the negative 90 there. Okay, negative 87 is this. If I go around, again, in that negative direction, I'm taking negative 87 degrees minus 360 degrees, which equals negative 447 degrees. There's one. If I take negative 87 degrees plus 360 degrees, I think we're talking 273 degrees. That's if I go this direction. That's my 273 till I get just 3 degrees past 270. All right, those are the two answers I would give there. Now, I'm going to take the same process, only now I'm going to add and subtract 2 pi. So 7 pi over 18, this is for number 5, plus, I'm going to write 36 pi over 18 instead of 2 pi. And that gives me 43 pi over 18. And then circle that. 7 pi over 18 minus 36 pi over 18. And that gives me negative 29 pi over 18. And there's my negative value. I am converting negative 210 degrees to radians. So I'm going to multiply it by a factor. And I got the 180 degrees on the bottom, so my degrees will cancel out because I'm converting it to radians. Not 2 pi radians. Pi radians goes with 180 degrees. So the degrees cancel out. 10s cancel out. 21, that's 3. So I've got negative 7 here, 6 here. So I'm going to go negative 7 pi over 6 radians. Notice I don't put radians if pi is like a factor there. We'll assume that. We won't be using degrees there. And here I've got 5 pi over 6. And this time I'm going to, instead of using pi over 180, I'm going to use 180 degrees over pi. Now our pi's will cancel out. The 6, I'll divide by 6 here, and that's 30. 5 times 30 is 150 degrees. All right, we're going to convert 271.35 degrees to degrees, minutes, seconds. So I got 271 and I'm going to take the 0.35 times 60. And that gives me 21 minutes. And if we wanted seconds, we don't have anything left over, so we'd have 0 seconds. If I had a decimal at the end of that, I would take that decimal and multiply it by 60, and I would have seconds there. Okay. 38 degrees, 20 minutes, 11 seconds. Round to the nearest thousandth. I'm going to take the 11 seconds and convert that to minutes and divide by 60 by doing that. 11 divided by 60 is 0.183. I may go an extra. That's minutes. And I also have that 20 to go along with that. And then I'm going to divide that by 60. I'm going to add 20 here. And divide that by 60. 0.336. And then that'll give me degrees. 38.336 degrees. is 38 degrees, 20 minutes, and 11 seconds. All right, number 10, find the length of the arc below to the nearest hundredth. Arc length is r times theta, but theta has to be in radians. So 315 degrees times pi over 180 degrees. I always want those degrees to cancel out. I kind of think of it that way. And the degrees cancel out. 45 times 7 is 315. 45 times 4 is 180. So radians, we're looking at 7 pi over 4 radians there. We're rounding to the nearest hundredth, so we probably could even do that as a decimal. I'm going to say that though. The arc length is r, which is 11 feet times 7 pi over 4. Let's do that calculation. 11 times 7 times pi divided by 4, 60.48. Let's get the units right. 60.48 length of the arc, and that's feet, so our answer is in feet. And this one, find the exact length of the arc here. And area is 1/2 r squared theta. You need to know the two formulas there. Area is 1/2 r squared theta. All right. Theta again has to be in radians, and 150 degrees. Look at here. Now we could go through and convert, but I already know that that's going to be 5 pi over 6 because we already did it. So the area here is 1/2 times 19 squared times 5 pi over 6. Well, this has to be exact. So I'm going to put the 2 times 6 over 12. I'm going to take 19 squared times 5, because it did say exact there. 1,805. So that is 1,805 pi over 12. The exact length, and that is feet. I would have just gone through like this, but I'm reading the instructions, and it does say exact there. Oh, Lord have mercy. Okay, well, let's go back. Length of the arc, exact length of the arc. I assumed that was a sector problem, and it wasn't, so now I'm going to go back. This is how you would do an area, sector area. Now we got to use this. Okay, so R is still 19. Theta is 5 pi over 6. Anyway, that would have been square feet looking back. So there's several issues there. So I'm going to write 95 pi over 6. Now I will put just feet there. Okay, that's my revised version of that problem. Okay, read the instructions very carefully. There's a lesson for you. All right, find the area. I'm looking at area now. I'm hyper-focused. and that is 1/2 r squared theta, 240 degrees. Theta still has to be in radians, so that's what I'm working on right now. 24, and we're going nearest hundredth, so, but I'm still going to write distance. 60 goes in both these. That's 4 and that's 3. So this is 4 pi over 3. So the area is 1/2 times r squared times 4 pi over 3. May as well put the 16 in there. 1/2 of 16 squared. I'm just going to plug that in. It says nearest hundredth, so I'm going to go 0.5 times 16 squared times 4 times pi divided by 3. 536.17. And that is square feet. All right. Number 13. Give the measure in degrees of the central angle that intercepts a 5.7 centimeter arc. So this is S. In a circle whose radius, that's R. Measure in degrees. Okay. S equals r theta. We could draw that. This is actually smaller. This is less than a radian because this arc is smaller than the radius. So we got 5.7 for the arc. The radius we have 10 theta. Divide by 10. Theta is equal to 0.57 radians. I'm going to multiply that by 180 degrees because this is in radians, but we are asking for degrees. So I'm going to take 180 degrees over pi radians, and the radians will cancel out. And it looks like I need to take 0.57 times 180 divided by pi. 0.57 times 180 divided by pi. And I get 32.66. This is approximately 32.66 degrees. Okay. We've got the angular speed and linear speed here. Find the angular speed in radians per minute. Okay. And what we have here is 4 revolutions per minute. And we want radians per minute. So 1 revolution is 2 pi radians. 1 complete trip around is 2 pi radians. If we're measuring the angle, that's 2 pi radians. So I'm going to multiply that by 2 pi radians per revolution. The revolutions cancel out, and we have radians here and minutes here, so we're talking about 8 pi radians per minute. And then on 15, the linear speed in miles per hour. Well, all we know right now, we know 4 revolutions per minute. Okay. Now I'm going to multiply that. The circumference is 50 feet times pi times diameter. That's what one revolution. If I go one revolution, I'm going 50 pi. So I'm going to multiply that by 50 pi feet per revolution. And my revolutions are canceling out there. Now the problem is I've got feet per minute and I want miles per hour. So I'm going to take, I'm going to deal with the feet. I'm going to take 5,280 feet per 1 mile. And that is going to cause the feet. So I've got the miles and it's on top, but I've got minutes here. And there's 60 minutes per hour, but I want the minutes to cancel, so I'll put 60 minutes up here, 1 hour down here, and my minutes will cancel. So my revolutions canceled, my minutes canceled here, feet canceled here, and I got miles over hours, I got miles per hour. So now it's all that's left is to do this calculation. It looks like 4 times 50 times pi times 1 times 60 divided by 5,280. Four times 50 times pi times 60 divided by 5,280. I'm going to go 2 decimal places there and say that this is 7.14 miles per hour. MPH is common there. All right, number 16. Sketch a right triangle corresponding to cotangent theta equals 7 over 2. Okay. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Sine is the reciprocal of, not secant, cosecant. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. All right. So cotangent theta, that's the adjacent side, and that is the opposite side. So I'm going to put 2 here. I'm going to put 7 here. I'm going to put my right triangle here because we're not dealing with the hypotenuse. And theta, opposite of theta is 2. So theta's right there. So cotangent theta is adjacent over opposite. 7 over 2. Tangent of theta is 2 over 7. That looks right to me, adjacent over opposite. Sine of theta, opposite over hypotenuse. I don't have the hypotenuse. So let's find the hypotenuse. And that's 4 plus 49, which is 53, and that's h squared. Take the square root. I only need the positive square root, so I'm going to go square root of 53 here. Opposite 2 over hypotenuse, square root of 53. Rationalize the denominator. And I got 2 2 radical 53 over 53 sine cosecant theta is hypotenuse over opposite, square root of 53 over 2. Now this one has a rational denominator, so I don't have to do anything with that. Let's go cosine theta is adjacent over hypotenuse, so 7 over square root of 53. Rationalize the denominator, and I got 7 radical 53 over 53. And then left is secant of theta, which is hypotenuse, square root of 53, over adjacent, which is 7. All right, there we go. Take care, guys.